Asking for the determinant of a huge matrix like this seems like a very difficult computation, or at least it feels like it's very cumbersome. But it turns out there's a really nice, quick way to do this using an identity. So the first thing you notice is you can write this matrix as the identity matrix, which has ones on the diagonal, plus a matrix that contains all ones everywhere. And to abbreviate that, we can write that as the identity matrix of dimension 7, plus this vector right here transpose times the vector itself. And this vector contains exactly 7 ones in it. So when you multiply these two, this being a 7 by 1 matrix and this being a 1 by 7 matrix, you get a 7 by 7 matrix of all ones. Okay, so the really cool property, which I actually mentioned in a previous video, is that if you take the determinant of the identity matrix times the product of two matrices, you can actually switch the order of these and add the identity matrix of the appropriate size and compute the determinant of that instead. Now, since this is a 7 by 1 matrix and this is a 1 by 7 matrix, when we do the swap, we get a 1 by 7 matrix times a 7 by 1 matrix. And the result is therefore a 1 by 1 matrix or a scalar number. So the dimension of the identity matrix of the appropriate size is actually a dimension 1 matrix, so it's just the number 1. And we're left with computing this dot product, and since there's exactly 7 ones in each matrix, the dot product is 7. And so we get 1 plus 7, which is 8.